and welcome to another episode of Twimmel Talk, the podcast where I interview interesting people doing interesting things in machine learning and artificial intelligence. I'm your host, Sam Charrington. The show you're about to hear is part 5 of our 5-part O'Reilly AI New York series, sponsored by Intel Nirvana. Now, if you've listened to the entire series, you've heard me say this again and again, but I am super grateful to them for helping make this series possible. And I'm also excited about the products and projects that they launched at the O'Reilly AI conference, including version 2.0 of their Nirvana framework and their new Nirvana Graph project. Be sure to check them out at intelnirvana.com. And if you haven't already listened to the first show in this series, where I interviewed Naveen Rao, the head of Intel's AI products group, and Hanlin Tang, an algorithms engineer on that team, it's Twimmel Talk number 31, and you definitely want to check it out. My guest for this show is Rana el Kaliouby. Rana is co-founder and CEO of Affectiva. If you remember my conversation about emotional AI with Pascale Fung from last year's O'Reilly AI conference, you're going to love this one. My conversation with Rana kind of picks up where that one left off, with a focus on how her company is bringing emotional AI services to market. It's a great conversation, and I know you'll love the show. Let's get to it. All right, everyone, I am on the line with Rana el Kaliouby, who is the co-founder and CEO of Affectiva. Rana was here at the O'Reilly AI conference and delivered a presentation on emotional AI. This topic may sound familiar to you because last year at the O'Reilly AI conference, I interviewed one of her colleagues in the field, Pascale Fung. And so I'm looking forward to speaking with you, Rana, to learn a little bit about Affectiva and how you're applying emotional AI and making it useful for enterprises. Welcome to the show, Rana.
Thanks, Sam. Thanks for having me. So, when we look at human intelligence, there's many aspects to that. And one important aspect is emotional intelligence. And that references the ability that we each have to read and understand other people's emotional and social and mental states, and then adapt our behavior accordingly. And so based on years of research, we know that people who have higher emotional intelligence tend to do better in life. They're more likable, they're more persuasive, they are more successful in their professional and personal lives, and they even live longer. So our thesis is that advanced AI systems and autonomous vehicles and all the technologies that are surrounding us today, they all have high cognitive intelligence, but they're really lacking in this emotional intelligence area. And we are, my team and I are on a mission to humanize technology by bringing in artificial emotional intelligence. We see that there are two sides to this coin. One is to build technologies and digital experiences and even devices that can sense emotion, consumers' emotional states in real time and adapt to that accordingly. So that's kind of one stream of work that we do. The other is more around gathering data about how people feel towards things. It could be online video ads or product concepts or new experiences. And we collect all that data and aggregate it. And as it turns out, this information is very, very important and meaningful for organizations as well as consumers.
Interesting. How did you get started in this area? What led you to study emotional AI?
So my own background as an undergraduate, I studied computer science. I was fascinated by the role technology plays in actually changing how we connect with one another as human beings. And then I got my first, living abroad opportunity. I got the opportunity to do my PhD at Cambridge University. And at the time I used to live in Egypt. So I moved to Cambridge, UK. And I realized I was spending more time with my laptop than I was with any other human being. Kind of sad. And of course it was frustrating because even though we were intimate, this laptop and I, it had absolutely no idea how I was feeling. So there were often times when I would be stressed because I had, a project deadline or a paper deadline, and it was just completely oblivious to all of that. But I also realized that it was my main portal of communication back to my family back home. And this was before we had smartphones. And I think it's still true with smartphones, right? Like you think of these devices and they are becoming the main portal of communication.
Absolutely.
Exactly. But yet I felt like even though, this kind of, social platforms have allowed us, and messaging apps and all that have allowed us to connect with more people, the quality of the connection is quite poor because a lot of the nuances and the nonverbals are kind of lost in cyberspace. So one example that really kind of stuck in my brain and has motivated a lot of my research. I remember feeling very lonely in Cambridge. And, I'd be chatting with my family back home and I'd be sometimes in tears, like I'd be really upset and they would have absolutely no clue until I send them that little emoji with tears, and then be like, oh, so you're kind of sad. And it was very explicit and it took away from the what do you call it? The sincerity of the emotion. And that made me realize that we could do better. And so I started imagining what would it take to build a computer that had some emotional intelligence skills the way my friend would or my mom does, and just got very interested in the psychology aspects of human emotional intelligence and then how to replicate that in a machine.
It is really interesting the degree to which, something as simple as an emoji expands the bandwidth we have for communicating emotion. And so I'm curious how you, with that as kind of a backdrop, tell us a little bit about Affectiva and the specific things that you guys are offering to allow companies to better, harness emotion.
Yeah. So like all great things, I came to Affectiva, by accident. So my career plan was to do my PhD and then apply for a faculty position and to take an academic and research career. I ended up joining Professor Rosalind Picard's group at MIT Media Lab. So she wrote the book Affective Computing in the late 90s. And that's kind of what inspired me to get into this research space.
Okay.
And I met with her and ended up joining her lab at MIT in 2006. And she and I collaborated on the application of emotion sensing to specifically mental health. And being at MIT Media Lab, twice a year, we would invite all these sponsor companies and they would say, you know what, we're very interested in this work you're doing. Like we want to apply to advertising research or, monitoring drivers in cars. There was just like a whole slew of applications. And after about 4 years of doing this at MIT, we decided that there was a commercial opportunity and that the market was ready for, this kind of technology. So we spun Affectiva out of the Media Lab.
Okay.
With the vision of bringing emotion AI to the market in a commercializable way. And it's been a few years. We found that, we still have a very broad vision. We still see that this technology is a core AI capability that's going to play in a lot of areas. The idea is to sequence the markets. And so the first use case, if you like, where we've applied this technology is in advertising research and market research. And the problem we're solving there is, think about Coca-Cola or Kellogg's or Pepsi. They want to understand how people are engaging emotionally with their content.
Interesting.
Yeah, because emotions drive behavior. So,
right?
If you feel very positive or inspired by an ad, you're going to share it with your network. You're going to go out and, you're going to build a positive brand affinity or loyalty. You're going to buy the product. So a lot of the marketers and advertisers we work with want to elicit a very strong positive emotion, or sometimes it's sentimental and it's not necessarily positive, but they want to drive an emotional journey, but they struggle to measure how effective they are at doing it. And before our technology, what they did is they just asked people, okay, how are you feeling about this? And we know that this is very unreliable and susceptible to all sorts of bias.
Right. It's expensive as well.
Correct. So what we do instead is we use our technology, which is essentially a machine learning and a computer vision platform that uses a camera on any device and it reads your facial expressions in real time and it maps it to an emotional state.
Oh, interesting. So do you position it as kind of a virtual focus group type of opportunity, or is it more, I guess, passive observation of people engaging in, real media experiences? Does that question make sense?
Yes, absolutely. It's both. So
okay.
Most of the work we've done to date is the latter. So we send people a URL and we say, okay, if you click on this, do we have your permission to turn the camera on while you're watching this movie trailer? Right. And if they say yes, all they do is they watch the movie trailer, the camera's on, it's streaming their responses. We do that for 1,000 people, and then we aggregate their responses, and that dashboard, that moment by moment journey, is what we present to the client or the TV studio.
Okay. Interesting. I can't help but think about a conversation that I had yesterday with Reza Zadeh. Do you know Reza from Matrioid?
I don't. Maybe I should connect us.
What he and his company is doing is they are indexing TV streams and allowing companies to build detectors that can identify, different brands and objects in the TV screen, in the streams, not necessarily TV, but, media streams. And I wonder if the degree to which some of the brands, as they have, the product placements are huge in some of these TV shows and things like that, if they'd get some additional insight by having kind of real-time, detection of emotional response to product placement, kind of in situ, in context, in a media, as media is being consumed. Random thought.
We often get asked, we will often get approached by an advertiser who, the ad, they are featuring two celebrities and they want to know which version resonates the most. Or, they often play with different product placements or different music in the background. And the idea is to really detect, because it's often hard for people to articulate if they've liked something. It's very hard to articulate what is it that resonated. And so we can detect your visceral reaction on a frame by frame basis. So we can say, okay, when the product reveal happened, this is what we saw.
And I've got to imagine that for, obviously emotion is very subtle. And the expression of emotion, particularly where I'm assuming you're using laptop cameras and we're primarily looking at face, we're talking about fine motor movements, things like that. How do you convince the skeptic that, this technology can really accurately pinpoint an emotional response?
So when we first started doing this work, the very first question we had to answer was, when you're in front of a laptop, do you even emote, right? Because there's no other human, right?
But I'm smiling and laughing as I'm in front of my laptop now as I'm engaging with you. But yes, I definitely get the question.
Right. If you're just watching an online video ad, do you even show any expressions? And so we collected, I mean, now, to date, we've collected 5.5 million face videos from 75 countries in the world of people interacting with their laptops, with their phones, playing games, driving in cars. So we have a very substantive data set of people's emotions. But when we first started, we did not have all this data. And so we initially collected data of people watching Super Bowl ads. And it was, we knew that some of them were successful and went viral and garnered a lot of attention, and some of them didn't. And we found that, yes, people emote expressions, even if there is no other human being present. And we saw the entire gamut of expressions. We saw laughter. We saw smirks when people were kind of, really skeptical. We saw confusion. We saw boredom. And that data set became the data that we use to train our algorithms. So we use, deep learning to train models to detect very, very nuanced expressions. The machine's now able to, or the algorithm is now able to identify 20 different facial expressions, and it maps them to 8 different emotional states. And just to give you an example, some of the expressions that we're able to identify now include a smile or a brow furrow, which are kind of obvious, but then it also is able to read like a lip suck or an eye squint, like very, very fleeting, nuanced expressions. And that's right. All because we have the data to drive the machine learning.
And I recall from Pascale that there's a standardized chart for emotions. Like there are two axes and the emotions are mapped out on these axes. Do you know what I'm referring to? And can you remind me what that's called?
Yes. So there's a circumplex model of emotions, and basically that maps, or it's the dimensional model of emotions. So it posits that you can think of emotions in terms of these main dimensions like valence. Valence is how positive or negative your experience is. Mm-hmm. And that actually is really, you can get a very accurate measure of valence from the face. And then the other axis is arousal, which is kind of the intensity of the emotion. Okay. And that is best quantified through your voice and also your physiology, like if you're measuring heart rate or heart rate variability or skin conductance.
Okay. And so is the implication then that your technology is primarily concerned with valence, or do you attempt to measure both and map everything onto this two-dimensional model?
So it's interesting because we have a valence measure and we have a proxy to arousal. We use level of engagement, which is, how much emotions are you showing, and also
gaze fixation and stuff like that.
Yeah, exactly.
Okay.
Are you paying attention or not? Are you fidgeting too much? So all of these measures could be kind of indirect proxies to arousal. But we're also very interested in measuring discrete emotions. So that's an alternative model for thinking about emotional states, and that is triangulating exactly what the emotion is. So is it joy? Is it surprise? Is it confusion? Is it contempt? And the face, again, is quite good at the specificity of the emotion, whereas if you're looking at, heart rate variability, it's often very hard to depict what kind of emotion is it, even though it's a high arousal emotion, but it's hard to tell what exactly it is. We also provide our partners and our customers with, a specific emotion measure, and we give you probability scores because sometimes they co-occur.
Sure. Have you applied this at all in the political sphere?
Not in the most recent political cycle. In fact, the most recent political cycle, we have a partner company called HireView. They are in the recruitment space. So they work with big companies that hire many, many people, and they have to screen, thousands of people. And instead of requiring that a candidate sends in a Word resume, you send in a short video interview. So,
oh, wow.
Yep. And then they use our technology to rank order the videos. So if you're applying for a sales position or a flight attendant, having social skills is really a key component of that job. And so we're able to quantify that. And so anyway, their position was that, the presidential debates are the ultimate job interview. Mm-hmm. So they used our technology to analyze both Trump and Clinton's expressions, and we published that, so it's available online.
Oh, interesting. I'll get the URL from you on that, and we'll include it in the show notes. Tell me a little bit about the underlying technology. You said it's based on deep learning. How has the technology evolved, and how would you characterize the approach?
Yeah, so we use deep learning. The idea is that we collect hundreds of thousands of images of people and videos of people expressing emotion in the wild. So it's not your selfies. It's not It's not like your Facebook profile pictures. It's actually people, sitting in front of a TV and just like chilling, right? Or driving around Boston in their car in the typical Boston traffic. So it's very spontaneous data, which means that it's very hard data. Like the background is messy. Sometimes it's quite dark. There's multiple people in the video. The expressions are not exaggerated. In fact, they're very nuanced and subtle. So it's real data. It's what you'd see in the real world. And we take that data, we get a portion of it labeled for training and a portion of it labeled for validation. And that becomes the data we inject into the convolutional neural nets. We also have temporal models because expressions are very dynamic and they unfold over time. And over the years, we've continued to accumulate this data. So we now have about 2 billion facial frames. Not all of it is labeled. And we've recently decided as a company that it's time to include other modalities. So we've started to research your emotions as they are represented in your voice as well, not just your face.
Okay. Makes sense. How did you collect all of this data? Do you have an app that provides some value to the consumer to incent them to just turn it on when they're driving or watching TV, or is it all via clients? I mean, at some point you had to kickstart this or cold start it and accumulate data before you had clients. How did you go about doing that?
We partnered with the very, very first project we did was with Forbes, and we put this thing on their website. And you could just go watch Super Bowl ads with the camera turned on. Then you would see your emotional profile. But since then, we've done this in 75 countries around the world through partners. So we have partners that are collecting this data, as part of, testing ads.
Okay. No, it sounds a little bit like, was it OkCupid or the dating site that did the quizzes to get people to psychologically profile themselves? One of the dating services was known for doing these small personality quizzes that were kind of entertaining for the people that were participating in them, but as a result, they were helping the company collect lots of profile data. And you're doing something similar, it sounds like, with your partners around ads and other media experiences. So you're using convolutional neural nets, and you mentioned some time domain neural nets as well, like LSTMs, I'm imagining. What is can you tell me a little bit about the data pipeline? How do you manage all of this video and get it ready to train these networks?
Yeah, so we have a cloud-based infrastructure that we've invested a lot into building that over the years. So all of our data goes into S3. Then we use Amazon Web Services to do all the so all the training is done in the cloud. We also built our own cloud-based data labeling or video labeling infrastructure. So, and we have a team of certified, face coders who, basically their job is to watch these videos and identify when an emotional expression occurs. And then we've built, again, in the cloud, we have this infrastructure that takes all this data and says, okay, there's agreement on this set of videos. There's no agreement on this set of videos. If there is agreement on a set of videos, that becomes, split. It gets split into training and validation data. And if there's no agreement, it goes back to the labeling pile. We also use active learning because we have a ton of videos. A lot of it has no emotions. Like if you're driving around Boston, for the most part, you're just neutral. We don't necessarily care about all of these frames. So we use what we call active learning, which is we use the machine learning models to bootstrap the labeling. So the machine takes a first stab at the labels, and then based on what the machine says, we either fork it to to actual human labelers for more labeling and more fine tuning, or we kind of, not throw that data away, but we park the data if it's not interesting. So it's a human in the loop labeling infrastructure. And then once we have that, we say, for instance, so let me take a step back. We do have a cloud-based set of APIs where you would send a set of frames or videos, and we would send you back the emotion probabilities in that video. And a lot of our partners use the technology that way. We call it emotion as a service. But we also have a number of partners that are developing real-time experiences. Like think of a social robot that needs to respond to you in real time, or Amazon Alexa kind of device.
Right.
And so we can't be streaming, tons of videos to the cloud and waiting for a response. And in that case, we have developed on-device software development kits so that you could integrate the core engine into your device or your app and have everything run on the device. You don't need to talk to the cloud at all. And so in that case, there's a trade-off between accuracy and speed and computational weight, how lightweight is it? And so we run experiments in the cloud, where we say, okay, we're going to train with, 200,000 samples, and we are going to evaluate this model on how accurate it is across all these different emotions, but also how fast it is and how heavy it is. And that all happens in the cloud, and our scientists, will evaluate. We come in the morning and there's a spreadsheet of all the different experiments that were run overnight, and our team will kind of evaluate, okay, which ones, if we want one for the mobile SDK, then we're going to really care about how fast it is and how lightweight it is. Does that make sense?
Oh, it does. It does. So this mobile SDK, what are the platforms that runs on?
We have it running on iOS, Android, Unity, 3D, Raspberry Pi, which was quite challenging, Windows, Linux, Mac OS X.
And was Raspberry Pi challenging because of RAM and CPU limitations?
Yeah, exactly.
Okay. And is the idea with a Raspberry Pi type of implementation that it might be the back-end compute module for a camera that's doing, some kind of set-top box or surveillance type of application?
We stay away from surveillance applications, but set-top box or, a connected home device that is, that is powering a social robot or, a home monitor.
Mm-hmm. And why do you stay away from surveillance? Is that an ideological decision or a technological decision?
It's ideological. So when we spun out, my co-founder Rosalind Picard and I basically made a decision that we would, in respecting how important and how personal this data is, that we would only work in use cases or industries where you knew that the camera was on and you knew that you were being analyzed in this way. And we would veer away or steer away from applications where that was not the case. Mm-hmm. We have stayed away from surveillance and security applications. Yeah.
Well, I certainly respect and appreciate that. I've seen some very scary surveillance demos recently, and to imagine layering on this emotional context, which I'm, it's one of those things. It's always one of those things where like someone's going to do it at some point, but I can appreciate your decision to not be that someone that does it.
Right. Our thesis is if we're going to spend a lot of our mind share and our passion and our energy solving a problem, there's a lot of other problems we can solve. Yeah.
Right. Where do you see the space going?
Yeah, very exciting. So the ultimate vision is that our devices and our technologies are going to have emotion AI embedded in them. We see a world where, this is going to run passively in your phone. It's going to track your mood. And on the path to that, we're seeing a lot more interest in the automotive space, for instance, where our kind of technology can help improve safety, especially in a world where we have semi-autonomous vehicles. So you can imagine, your car is on autopilot, but it may need to relinquish control back to you as a driver. And so the question becomes, in a matter of seconds, it needs to know, are you awake or not? Are you paying attention or not? And that's where our technology comes into play.
Yeah, I can also imagine a world where you've got digital billboards and you have some driver opt in to this system. Maybe they get, some benefit or compensation, but you're reading their emotion as they're engaging, quote unquote, with these billboards. Lots of interesting applications. And I can, certainly I was going to talk about, being a New York City born and bred driver and road rage, but I probably won't go there, and producers will cut this segment out of the conversation.
Road rage is definitely one of the emotions that we get asked about. But there's also...
Is it really?
Oh, yes. Yes. Road rage, drowsiness, distraction. And you know what, too? Like just general infotainment. So a lot of these cars are now rethinking the brand experience, the in-cab brand experience, and they want to, get a sense of the sentiment inside the vehicle, not just the driver or the co-pilot, but also the passengers, and adapt the experience, adapt the lighting, adapt the music, adapt the general environment, and personalize it. So we get a lot of interest around that as well.
Okay, so that's where the business and use cases are going. Where do you see the technology going to? Are there things the technology needs to go to enable these, new and more ubiquitous use cases?
Yeah, definitely multimodal. So combining both, computer vision with speech to get a better understanding of how you feel, or, your social and emotional signals. And that's especially important in conversational contexts. So
Okay.
it's okay to just focus on your facial expression if you're just watching a movie, that's fine. But if you are in a conversation with a chatbot or a personal assistant or, a social robot or your car, then combining all these different modalities is going to be key. So that's definitely one class of product development and kind of, core science development that we're focused on. But just more generally, there's a lot of applications in, say, healthcare, where there has been academic research that showed that, your facial expressions and your voice can be biomarkers for pain, can be biomarkers for depression, even suicide assessment.
Oh, wow.
So I would like to really see the technology move into that area, and that would require, substantial data collection of a healthy population versus, a depressed population. But I think that's where the technology can be really transformative.
Fantastic. Fantastic. Well, thank you so much for taking the time to speak with us. These applications, this whole emotional space is one that I find really fascinating, and I'll definitely be keeping my eye on what you guys are doing. And I wish you the best of luck. Thanks so much.
Thank you. Thanks for having me, Sam.
All right. Thanks, Rana. All right, everyone. That is our show. Thanks so much for listening and for your continued support, comments, and feedback. A special thanks goes out to our series sponsor, Intel Nirvana. If you didn't catch the first show in this series, where I talked to Naveen Rao, the head of Intel's AI product group, about how they plan to leverage their leading position and proven history in silicon innovation to transform the world of AI, you're going to want to check that out next. For more information about Intel Nirvana's AI platform, visit intelnirvana.com. Remember that with this series, we've kicked off our giveaway for tickets to the AI conference. To enter, just let us know what you think about any of the podcasts in this series, or post your favorite quote from any of them on the show notes page, on Twitter, or via any of our social media channels. Make sure to mention @TwimmlAI, @IntelAI, and @TheAIConf so that we know you want to enter the contest. Full details can be found on the series page, and of course, all entrants get one of our slick Twimml laptop stickers. Speaking of the series page, you can find links to all of the individual show notes pages by visiting twimlai.com/O'ReillyAINY. Thanks so much for listening, and catch you next time.